So here is an Alex problem, predictions from the least squares regression line. The Cadet is a popular model of sport utility vehicle known for its relatively high resale value. The bivariate data, that means two variables, x and y. Okay, that's all that word means. Given below, were taken from a sample of 16 cadets, each bought new 2 years ago, and each sold within the past month. For each cadet in the sample, we have listed both the mileage x that the cadet had on its odometer and the price y. With the aim of predicting the used selling price from the number of miles driven, we might examine the least squares regression line. This line is shown in the scatter plot. So here's all the points, 27, 30. So one value is over here at 27. X is 27. Did I not get a pen? Oops, what did I do? So X is over here at 27, and Y is at 30. So there's a point at about 27, 30, up in this area, one of these, okay? 27, 30 makes an ordered pair. Then we've graphed all of those ordered pairs, and they've drawn the least squares regression line, and they tell you that it is 40.77 minus 0.46x. The minus sign here tells you that this graph slopes downward. Okay, there's my attempt at an arrow. This graph slopes downward, okay? And 40.77 is where it would cross the x-axis. It doesn't look like it's going to cross there because this graph is broken. These two little lines that go across it tell you that there's more to the graph that's missing. It causes these lines to not hit apparently where they should, but don't worry about that. It tells you here the number 40.77 is your B. So our job is to figure out these four things. Fill in the blank. For these data, mileage that are less than the mean of the mileages that are less than the mean of the mileages tend to be paired with used selling prices that are less than, greater than, or equal to. So if we're talking about means that are mileages that are less than the mean, well, if the mean is here someplace in the middle, well, mileages to the left are going to be higher, okay? Mileages to the left are higher because of the negative slope. So our first answer is going to be greater than. According to the regression equation, for an increase of 1,000 miles in cadet mileage, there is a corresponding decrease of how many $1,000? So looking at our equation, an increase of 1,000x is going to be a decrease of 0.46 because of the minus 0.46 times each x. So the 0.46,000, that's going to be just the slope. From the regression equation, what is the predicted used selling price when the mileage is 26.1? So then we just plug in, here's our equation, and we plug in the 26.1 from the problem, and working it out, 0.46 times 26.1 is 12.06, and so 40.77 minus 12.06 is about 28.8. And then from the regression equation, what's the predicted used selling price when the mileage is 29.5? That's just repeating the same process for 29.5. And so that would be predicted to be $27.2 thousand. The questions on that?